Yes. In the last class, we discussed about the electrolytes and non-electrolytes and strong electrolytes and weak electrolytes. Extension of this one is acids and bases. Acids and bases. Acids and bases. You know that the acids, what do you mean by acids? What are the general characteristic properties of the acids? They are sour to taste. Sour to taste. Sour to taste. And they changes blue litmus paper color to red. They changes blue litmus paper color to red. Blue litmus paper to red. Blue litmus paper to red. And they reacts with metals, they liberate hydrogen. They liberates hydrogen with metals, means with chemical reaction with the metals. These are the very important properties that you already studied at the school level. Acids are sour to taste. They changes blue litmus paper color to red color, and they liberates hydrogen gas with that of the metals. Good examples are hydrochloric acid, sulfuric acid, nitric acid, acetic acid, formic acid. These are acids. Yesterday we discussed these are electrolytes. Some of them are strong electrolytes and some of them are weak electrolytes. Now, what do you mean by acids? In case of hydrochloric acid that decomposes to give off is H plus ions and Cl minus ions in aqueous medium. That is in water medium. In aqueous medium. Aqueous medium here corresponds to water medium. Similarly, hydrochloric acid, sulfuric acid, nitric acid, they ionizes to give and HNO3 that ionizes to give off H plus ion and nitrate anion in aqueous medium. Aqueous medium here corresponds to water medium. Similarly, sulfuric acid that ionizes to give H plus ion and bisulfate anion. In aqueous medium. See, they liberate hydrogen ion. Here it liberates hydrogen ion. Here it liberates hydrogen ion. Therefore, these are the chemical substances that produces hydrogen ions in aqueous solution. And some of the molecules, for example, this is first molecule, this is second molecule, and this is third molecule. And you know that the fourth molecule is here. For example, acetic acid that ionizes to give off acetate ion and H plus ion, CH3CO minus and H plus, CH3CO minus. For weak electrolytes, you have to represent like arrow mark on both sides because there does not require complete ionization. Therefore, the forward reaction is not possible 100%. That is why they are equilibrium with that of the undissociated molecules. And then formic acid, HCOOH, formic acid, then it is in equilibrium with formate ion, HCOO minus, formate ion and H plus ion, formate ion and H plus ion. Only in case of the strong acids you have to represent this R mark in forward direction. In case of weak acids or weak electrolytes, you have to represent in both directions, because acetic acid is the weak acid and formic acid is the weak acid, and hydrochloric acid, nitric acid and sulfuric acids are strong acids. Now what do you mean by this acids according to Arrhenius? Oldest theory that helps to identify an acid, that is a chemical substance which undergoes ionization in aqueous medium with the liberation of the hydrogen ion is called an acid. A chemical substance which undergoes ionization reaction in aqueous medium with the liberation of the hydrogen ion is called an acid. That was proposed by Mr. of the Arrhenius, and this theory is often called as a Arrhenius theory for acids. Arrhenius theory for acids. Now according to Arrhenius theory, acids are the substances which dissociates producing H plus ions when they dissolved in water. Therefore, according to Arrhenius theory, acid is a substance which undergoes ionization in aqueous medium with the liberation of the hydrogen ions. Acid. Arrhenius theory of an acid. Arrhenius theory of an acid. Acids are the substances which dissociates producing H plus ions dissolved in water. Arrhenius. Arrhenius theory. Arrhenius theory of an acid. Arrhenius theory of an acid. Acids are chemical substances that dissociates. Acids are substances which dissociates producing. Acids are substances. Acids are substances dissociates to produce H plus ions in aqueous medium. Dissociates to produce H plus ions in aqueous medium, or when dissolved in water, when dissolved in water. Arrhenius theory. According to Arrhenius theory, acids are substances which dissociates to produce producing H plus ions, producing H plus ions, producing H plus ions in aqueous medium. This is about the definition of the Arrhenius theory. Acids are substances dissociates producing H plus ions in aqueous medium or when dissolved in water. When hydrochloric acids, nitric acid, sulfuric acid, acetic acid or formic acid, when they dissolved in water, then they produces H plus ions, and hence these are Arrhenius acids. Examples for Arrhenius acids. Examples for Arrhenius acids. Examples for A should be capital. Examples for Arrhenius acids. Examples for Arrhenius acids. Hydrochloric acid is an example for Arrhenius acid. Nitric acid is an example for Arrhenius acid. Sulfuric acid is an example for Arrhenius acid, and even acetic acid is an example for Arrhenius acid, And even formic acid is an example for arenes acid, because when they dissolved in water medium or aqueous medium, they have ability to give off the hydrogen ions. They have ability to give off the hydrogen ions. Even HCN molecule is also there, which undergoes ionization reaction. Even HCN molecule is also there, which undergoes ionization reaction in aqueous medium. It liberates H plus ion, HCN, because that is a weak electrolyte. Then it gives rise to H plus ions and Cn minus ion, H plus ion and Cn minus ion. Now that is truly in case of aqueous medium. In aqueous medium, in water medium or aqueous medium, in water medium. That is same in water medium. That is same in water medium. In water medium only they have ability to give off the H plus ions. Okay. This is about the definition of the arenes acids. Now some of the compounds like that of the bases, like that of this sodium hydroxide, potassium hydroxide, if suppose that ends with the hydroxide, like ammonium hydroxide, barium hydroxide, magnesium hydroxide, aluminum hydroxide, whatever it may be, and some of the compounds like that of the sodium carbonate, bases, these are soapy to touch and bitter to taste. What means of the bases? What do you mean by that of the bases? How do you give the definition of the bases? They are bitter to taste. Whereas the acids are sour to taste. These are bitter to taste. And one more is the turns red litmus paper color to blue. They turns red litmus paper color to blue. Red litmus paper to blue. They turns red litmus paper to blue. And they react with acids, undergoes neutralization reaction. They undergoes neutralization reaction with acid. They undergoes neutralization reaction with acids. Undergoes neutralization reaction with acids. Neutralization reaction with acids. Neutralization reaction with acids. Undergoes neutralization reaction with acids. Is it clear? These are the soapy to touch, and one more is there. They are soapy to touch. Soapy to touch. Soapy to touch. These are already you studied in school level. What are the bases? Good examples for the bases like that of the sodium hydroxide, potassium hydroxide, ammonium hydroxide, magnesium hydroxide, aluminum hydroxide, and so on. Whereas examples for these molecules are, whereas the sodium hydroxide is the base, that is called as an alkali, and potassium hydroxide is a base, that is called alkali, and ammonium hydroxide is a base. Ammonium hydroxide is a base. You know that of calcium hydroxide, there is milk of, there is a calcium hydroxide, there is a slacked line, and magnesium hydroxide used in antacid gels. Magnesium hydroxide that is used in antacid gels. That is in acidity. You are using this in the form of the medicine. That is a magnesium hydroxide. This is calcium hydroxide. That is called as a milk of lamb. That is there is a magnesium hydroxide. Now, what do you mean by the base? What do you mean by the bases? According to Arrhenius theory. According to Arrhenius theory. How to define base? According to Arrhenius theory, how to define the base? Therefore, a chemical substance which undergoes dissociation in aqueous medium with the liberation of the hydroxyl ion, they are called bases. Bases are the substances which dissociates, producing hydroxyl ions when dissolved in water. Therefore, base is a chemical substance which undergoes dissociation producing hydroxyl ion in water medium. Therefore, see, H plus ions in water medium are called acids. Hydroxyl ions in water medium are called as a bases. Therefore, how do you define the Arrhenius base? Arrhenius base. Bases are substances. Bases are substances. Bases are substances. Bases are the 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 substances which dissociate producing. Which dissociates producing. Which dissociates. Which dissociates producing. Which dissociates producing hydroxyl ions. Hydroxyl ions. Which dissociates producing hydroxyl ions. Hydroxyl ions when dissolved in water. Hydroxyl ions when dissolved in water. When dissolved in water. When dissolved in water. What about pronunciation? There is OH is equal to hydroxyl ions. Hydroxyl ions. Hydroxyl ions in water medium or aqueous medium. Dissolved in water, or you can call it as an aqueous medium. Aqueous medium or water medium. Aqueous medium or water medium. Then NaOH. NaOH. That undergoes cyanation. Then it gives rise to Na plus OH minus. NaOH that gives rise to Na plus OH minus. That is in aqueous medium. In aqueous medium. In aqueous medium. And KOH. KOH. That ionizes to give. That is a K plus OH minus. K plus OH minus in aqueous medium. K plus in aqueous medium. Similarly, ammonium hydroxide. Ammonium hydroxide. Since it is a weak electrolyte, the arrow mark on two sides, then it gives rise to NH4 plus OH minus. NH4 plus OH minus. That is also in aqueous medium. Aqueous medium. Aqueous medium is when they are put it in water. That is called aqueous medium. Is it clear? Now this is about definitions for Arrhenius acids and Arrhenius bases. Note that a chemical compounds which contains H plus ions are called acids. A chemical compounds which contains hydroxyl ions, they are called as bases. This is about the Arrhenius concept of acids and bases. It has limitations. It has limitations. Most of the molecules, some of the molecules like that of the calcium oxide or calcium barium oxide or magnesium oxide or metallic oxides. Some of metallic oxides are basic in nature. Some of the compounds like that of the carbon dioxide, nitrogen dioxide, these are shows the acidic characteristics, but this does not give the information about why this carbon dioxide or why the sulfur dioxide or sulfur trioxide they are not considered as acids and base category. Now, what about the limitations of the Arrhenius theory? Limitations of the Arrhenius theory. 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 That is nothing but disadvantages. Initially they proposed, but there are certain disadvantages. And according to this concept, acidic and basic characteristic can be explained only in the presence of water medium. That is the drawback. Some of the compounds like that of metallic oxides, which are metallic oxides, they have ability to behave like that of the bases, and carbon dioxide, sulfur trioxide, nitrogen dioxide, nitrogen pentoxide. These are the substances which also shows the acidic characteristic, and metallic oxides, they shows the basic characteristic. But Arrhenius theory, that does not satisfactorily explain the existence of the acidic characteristics of the non-metallic oxides and basic characteristics of the metallic oxides. But only water is essential, that is aqueous medium is required to explain the acidic and basic characteristics of an acid. That is the first drawback of the Arrhenius acid and Arrhenius base. Arrhenius theory explains acidic and basic characteristic property. Arrhenius theory explains the concept of acid and bases only in water. First one, Arrhenius concept, Arrhenius theory explain the concept of acid and base. Arrhenius explain the concept of acids and bases only in aqueous medium. Aqueous medium is necessary to explain, because after dissociation only they have ability to produce the H plus ions. Arrhenius theory does not explain the amphoteric natures of the substances. Like Arrhenius theory does not explain the Arrhenius theory does not explains the amphoteric nature of water and ammonia. Whereas they exhibit both the characteristic properties. Whereas water that exhibit the acidic characteristic and alkali characteristic property, ammonia also exhibit acidic characteristic and alkali characteristic, because these are two compounds are called amphoteric substances. What about amphoteric substances? Because water has ability to give off the H plus ion, and hence we can call as an acid according to Arrhenius theory. Similarly, water has ability to give off the hydroxyl ion, and hence according to Arrhenius theory, it behaves like a base. Such type of the compounds are called amphoteric, means the dual nature. Whereas H plus ion is generated by means of the water, therefore water is an acid. OH minus is generated by means of water, therefore water is a base. Can I call water is an acid or water is a base? No, water is an amphoteric nature. What is meant by amphoteric substances? Chemical substances which gives the characteristic properties of both acids and bases are called amphoteric properties. Whereas water is an amphoteric property. It has ability to donate a proton as well as accept a proton. Ammonia, it has ability to donate a proton as well as accept a proton, and hence this water and ammonia, they are considered as amphoteric substances. Now, some of the molecules like that of the electron deficient species, like that of the boron trifluoride, aluminum trichloride, these are considered as electron deficient species. In electron deficient species, they are used as a catalyst in so many organic chemical reactions, where they have ability to abstract that of the negative species, electronegative species. Such type of the molecules are considered as acids. That's called as Lewis acids. Actually, in future I will explain the next session what I mean by the Lewis acids. Therefore, electron deficient nature of the molecules, that is a BF3 molecule, a real Cl3 molecules, that can be explained. This theory does not explain why the compounds like boron trifluoride and aluminum trichloride are acidic. This theory does not satisfactorily explain. Arrhenius theory does not satisfactorily explain. Arrhenius theory does not explain the acidic nature of, does not explain the acidic nature of boron trifluoride, acidic nature of boron trifluoride and aluminum trichloride. Boron trifluoride and aluminum trichloride. They are considered as acidic molecules, acidic nature of boron trifluoride and aluminum trichloride. It does not explain some of the molecules like that of the calcium oxide and ammonia. Arrhenius theory does not explain the basic characteristics of Arrhenius theory. Arrhenius theory does not explain the basic nature of calcium oxide and magnesium oxide. These are the ammonia, calcium oxide and ammonia, even metallic oxide is also there. Ammonia is the basic nature, calcium oxide is also basic nature. They cannot be satisfactorily explained by using this Arrhenius theory. Therefore, these are considered as limitations of the Arrhenius theory. And one more is that it donates H plus ion, but the size of the H plus ion is very less. That is in the range of 10 to the power of minus 15 unit. But with a small that H plus ion, it does not exist in aqueous medium. Now H plus ion, suppose it is related in aqueous medium, it has ability to form a coordinate bond with that of the lone pair of the electrons in the oxygen by means of a coordinate chemical bond. Therefore, actually H plus ion does not exist in water medium. It is associated with that of the water molecule, because a small cation that is surrounded by means of the sheath of the water molecule, then at least the formation of the hydronium ion. There is a protonated water molecule is called as a hydronium ion. There is a new concept, H2O molecule that combines with that of the H plus ion, then it gives rise to H3O plus ion. This H3O plus ion is called as a hydronium ion. Therefore, very important one, actually H plus ion is not there. H plus ion is a proton which has the size about 10 to the power of minus 15 unit. H plus ion is a proton. 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 Has a small size. That is in the range of 10 to the power of minus 15 meter. 15 meter. Therefore, 15 meter. Such a small electrically charged particle cannot exist. Such a small electrically charged particle does not exist in water medium. Charged particle cannot exist free in water. Cannot exist free in water. This implies that it forms one coordinate chemical bond. It gets hydrated. And forms one coordinate bond with water. Coordinate bond with water. Like this HOH. This is water structure plus H plus. Then it forms one coordinate chemical bond. Then it leads to structure like this. This ion is called as a hydronium ion. This ion is called as a hydronium ion. That is a protonated water molecule is called as a hydronium ion. This is called as a hydronium ion. This is called as a hydronium ion. This is called as hydronium ion. What do you mean by hydronium ion? Protonated water molecule is called as a hydronium ion. The hydrated hydrogen is called hydronium ion. Hydrated hydrogen is called hydronium ion. Very important definition. What do you mean by hydronium ion? Important definition of hydronium ion. Definition of hydronium ion. Protonated hydrated hydrogen. Hydrated hydrogen. Hydrated hydrogen, that is H3O plus, is called hydronium ion. Hydronium ion, which is nothing but protonated water molecule is also called as a hydronium ion. Protonated water molecule. Protonated water molecule is called hydronium ion. Protonated water molecule is called hydronium ion. Representation is H3O plus. Representation is H3O plus. Now these are the some of the limitations of the Arrhenius theory. Some of the limitations of the Arrhenius theory. Then Bronsted next theory is put forward. In order to overcome the limitation, Bronsted he put forward one more theory for acid and base, that is called Bronsted theory. Bronsted theory, proton transfer theory or Bronsted theory. Next one is Bronsted theory. Bronsted theory or proton transfer theory. Proton transfer theory. Bronsted theory or proton transfer theory. Now what is proton transfer theory? You know what the hydrogen ion is nothing but a proton. According to hydrogen ion, hydrogen ion is nothing but your proton. Hydrogen ion is nothing but a proton. Therefore, hydrogen ion donors are called acids, nothing but proton donors are called acids. Hydrogen ion donors are called acid is replaced by proton donors are called acids. Hydrogen ion donors. Hydrogen ion donors are called. Hydrogen ion donors are called acids. Whereas the Bronsted just replace this hydrogen ion by means of proton, that's all. Because hydrogen is the atom which contains only proton, one electron, neutron, no neutrons are there. That is the beauty of the hydrogen atom. Hydrogen is the unique element which does not contains neutron in the nucleus. Therefore, hydrogen structurally it contains one proton in the nucleus and no neutron in the nucleus, one electron that surrounds the nucleus in first shell. That is an s atomic orbital. When electron is lost by means of the hydrogen atom, then we got that of the H plus ion. This H plus ion, what is it contains? It contains only proton. Therefore, H plus ion donor is called as nothing but in the proton donors are called as. That is why this theory is often called as a proton donor acceptor theory. The phenomenon is often called as a proton donor acceptor theory. That is why this is proton donor theory. Proton transfer means proton donor and proton acceptor theory is called the Bronsted theory. What are the limitations of the Arrhenius theory are overcome by means of this Bronsted theory? Limitations of the Arrhenius theory are overcome by means of the Bronsted theory. Limitations of the Arrhenius theory are overcome. Limitations of Arrhenius theory. Limitations of Arrhenius theory. Limitations of Arrhenius theory are overcome by Bronsted theory. Are overcome by Bronsted theory. Bronsted theory. According to this, suppose whenever hydrochloric acid is put it in water, then what happens? Hydrochloric acid, when you put it in water, then it gives rise to Cl minus ion and hydronium ion. Cl minus ion and hydronium ion. Cl minus ion and hydronium ion. Similarly, when nitric acid is put it in water, what happens? Nitric acid is put it in water, HNO3. When it is put it in water, then what happens? Then H plus ions are donated to this H2O. Therefore, it gives rise to NO3 minus plus H3O plus. NO3 minus plus H3O plus. Now, of course, you are calling this is an acid. This is an acid. Call this an acid. Then it seems to be base. And here it is a base. And it is an acid. It is a base and this is an acid. Assume that is acid 1 and this is base 1. This is base 2 and this is acid 2. Base 2 and acid 2. See, now this HCl has ability to donate a proton. Therefore, HCl is called as an acid. Where this proton goes? That proton goes to the water. Therefore, water accepts the proton, then it converts into hydronium ion. Therefore, here HCl and Cl minus. HCl is an acid. And Cl minus is a base. HCl is an acid and Cl minus is a base. And water is a base and hydronium ion is an acid. Hydronium ion is an acid. Assume suppose this is a base and this is considered an acid. These are the pair of the molecules which they differ by means of a single proton. Whereas hydrochloric acid and Cl minus, these are the pair of the molecules, they differ by means of one proton. When you add one proton to Cl minus, it becomes HCl. When you remove one proton from HCl, it becomes Cl minus. Similarly, in case of the H2 and hydronium ion, they differ by means of the one single proton. If you add one proton to this water molecule, it becomes hydronium ion. If you remove one proton from the hydronium ion, then it becomes that of the water molecule. Therefore, these type of the pair of the molecules which differ by means of the proton. These type of the substances, HCl and Cl minus and H2O and H3O plus. Similarly, we have this HNO3. Suppose call this is an acid. Acid number 1. This is base number 1. Acid number 1. This is base number 1. Then if it is an acid, consider this is a base. Therefore, what is a base? That is base number 1. This is suppose base number 2. Then this is acid number 2. Just identify this is acid and this base. And base and this acid. Here also, this is a hydrochloric acid that can be converted to Cl minus by removing one proton. H2O can be converted to H3O plus by means of adding an electron. Therefore, HNO3 and NO3 minus. They differ by means of the proton. And H2O and H3O plus. H3O plus. They differ by means of proton. These are called conjugate acid base pairs. These type of the molecules are called conjugate acid base pairs. Conjugate acid base pairs. There is a hydrochloric acid and Cl minus ions are conjugate acid base pairs. Water and hydronium ion, that pair is called conjugate acid base pair. Conjugate acid base pair. This nitric acid and nitrate ion is a conjugate acid base pair. Conjugate acid base pair. Water and hydronium ion is called conjugate acid base pair. Conjugate acid base pair. What about the conjugate acid base pairs? Pair of the molecules which differ by means of proton. Pair of molecules which differ by means of proton are called conjugate acid base pairs. Pair of the molecules that differ by means of proton are called conjugate acid base pairs. Pair of the molecules differ by means of proton are called conjugate acid base pairs. What is called conjugate acid base pairs. Pair of molecules differ by a proton are called conjugate acid base pairs. Are called conjugate acid base pairs. Conjugate acid base pairs. HCl is a conjugate HCl and Cl minus. HCl and Cl minus are conjugate acid base pairs. Are called conjugate acid base pairs. Are called conjugate acid base pairs. Conjugate acid base pairs. Conjugate acid base pairs. Here HCl is called conjugate acid of Cl minus. Conjugate acid of Cl minus. Cl minus is called conjugate base of HCl. Conjugate base of HCl. Suppose in entrance exam they will give identify the conjugate base of, then you have to subtract one H plus. Identify the conjugate acid of, you have to add one H plus. For a given species, if you remove the H plus ion, then it becomes conjugate base. For a given molecule or given species, if you add one H plus, that becomes conjugate acid. Okay, therefore HCl and similarly HNO3 and HNO3 and H2, HNO3 and H2O and H3O plus, H2O and H3O plus, suppose. Then according to this concept, H2O is a base, H3O plus is an acid. Therefore H2O is conjugate base of H2O is conjugate base of H2O is conjugate base of H3O plus, conjugate base of H3O plus. Similarly H3O plus is conjugate acid of H3O plus is conjugate acid of water. Conjugate acid of water. Conjugate acid of water. Similarly, we have HNO3 is a conjugate acid of NO3 minus. NO3 minus is a conjugate base of HNO3. HNO3 is a conjugate acid of NO3 minus. HNO3 is a conjugate. HNO3 is a conjugate acid of NO3 minus. NO3 minus. NO3 minus is conjugate base of HNO3. Conjugate base of HNO3. Whereas the trick is conjugate base plus H plus gives rise to conjugate acid. Conjugate acid minus H plus. Conjugate acid minus H plus, that gives rise to conjugate base. Conjugate base plus H plus is equal to conjugate acid. Conjugate acid minus H plus is equal to conjugate base. That is a trick how to remember the conjugate acid base pairs. Conjugate acid base pairs. Okay. Thank you. I'll continue the next class.